This is URK 19 CS 1093. Exercise number 6, doubly linked list. Question is to stimulate the working of doubly linked list with the following operations: insertion at beginning, insertion at end, insertion after specified node, deletion at beginning, deletion at the end, deletion of the node having given data, searching and display. So, doubly linked list contains an extra pointer, typically called previous pointer, together with next pointer and data which are there in singly linked list. Doubly linked list is a variation of linked list in which navigation is possible in both ways, either forward and backward easily as compared to single list. So let's go to the code. So here we are creating a struct node, so that we are declaring a data, integer data, and struct nodes, pointers next and pointer previous, and out of this struct node we are creating another struct node, that is pointer head. This is a function prototype for the insert at beginning, insert at end, insert at specified location, delete at beginning, delete at end, delete at specified location, search, display. And inside the main function we are asking the user to choose from the following options. For that we are using a switch case with the help of a while loop. The options will be printed and the user's choice will be stored into a variable called choice. In case 1 it will call insert back function. Case 2 it will call insert at end. Case 3 it will call insert under a specified location. Case 4 it will call for delete at beginning. Case 5 it will call for delete at end. Then case 6 it will call for delete at specified location. Case 7 it will call for search function. Case 8 it will call for display function, and case 9 it's exit. And if the user enters any invalid option, it will tell please enter valid choice as default. Then moving on, this is the function definition for insert back. So here we are declaring a struct node ptr, and we are allocating a memory space for it. And using if condition, we are checking whether ptr equal to null, and if it is equal to null, that means the linked list is like overflow, it's full. If this condition is wrong, then it will go to the else part where we have declaring an item and we are asking the user to enter the item. And then we are checking whether head equal to null if using if loop. And if this is correct, if this condition is true, then item will be stored into ptr of data, and null will be stored into ptr of previous, and null will be stored into ptr of next, and ptr will be stored into head. And if this condition is false, then it will go to the else part, and item will be stored into ptr of data, null will be stored into ptr of previous, head will be stored into ptr of next, and ptr will be stored into head of previous. Ptr will be stored into head. And coming out of the if and else, it will print node inserted. When the node is if the node is inserted, then it will print node inserted. Now moving to the function definition of insert at end, we are declaring two struct nodes, that is pointer ptr and pointer temp. This is to store temporary variable. Temp is for storing temporary variables. ptr, again we are allocating a memory space. We are declaring a data member, integer data member called item. We are asking the user to enter, and will be stored into the item. And we are storing that particular value entered by the user to ptr of data. And we are checking whether ptr equal to null. And if it is true, then it means it's overflowing. And if it is false, then we will come to the execute the else part where head equal to null, where null's value is stored into ptr of previous and null is stored into ptr of next, and head is equal to ptr. Else, if this condition is false, then it will store head's value into temp, which is used for temporary variable. And using a while loop, we will check whether temp of next not equal to null. If this condition is true, then temp of next will be stored into temp. And coming out of the while loop, ptr will be stored into temp of next, and temp will be stored into ptr of previous, and null will be stored into ptr of next. And coming out of the if and else, it will print node inserted, the node. Then coming to insert at specified location, again we are declaring two variables. We are storing memory for them, and we are asking the user to enter a value, and item will be stored into ptr of data. And using if condition, again we are checking the overflow condition. And coming to the else part, we are storing heads value into temp, and again we are declaring two integer variables log and I, which is means for location, to get the location from the user. And using a for loop, we are initializing I equal to 0, I less than log I plus plus. This is to get the location, and we'll store temp of next value into temp. And again using if condition, we'll check whether temp equal to null. If this condition is true, then it means location is not found. The particular value entered by the user, or the particular location entered by the user, is not found in the given thing. And temp value will be stored into ptr of previous, and temp of next value will be stored into ptr of next, and uh, ptr will be stored into temp of next of previous, and ptr is stored into temp of next, and it will print node inserted. Then this is the function definition for delete at beginning. We are declaring a variable ptr using struct node. We are checking the underflow condition where head equal to null. This is false. Then it will go to else if case where they'll check head of next equal to null. If this condition is true, then it will store all the values like head equal to head's value to ptr and null as head, and free of ptr, then print not deleted. If this condition is also false, then you will go to the else part where all these values will be stored to the particular uh, variables, and free of ptr, and will print not deleted. Now moving into delete addend definition, function definition. We are checking head equal to null, the underflow condition. If this is false, then we will go to the else if part where we'll check head of next equal to null. If this condition is true, then it will store all the values to the particular variables, and it will print not deleted. And if this condition is also false, it will move to the else part where head's value will be stored into ptr. And using a while loop, we will check ptr of next is not equal to null, and ptr of next value will be stored into ptr. And then null's value will be stored into ptr of previous and ptr of next, and it will print not deleted. And moving into delete specified definition, function definition. Here we are declaring three struct nodes, ptr, ptr1, and temp, and an integer data member called data. Here we'll enter the data after which the node is to be deleted. We are asking the user to enter a particular number after which the number should be deleted. So that will be stored into the variable data, and head's value will be stored into both ptr and ptr of 1. And using a while loop, we will be checking ptr of data not equal to data. If this condition is true, then ptr of next is stored into ptr. And if ptr equal to null, then it will print can't delete data not found. If the user enters some other number which is not in the given numbers, it will print can't delete data not found. And coming out of the this if condition, another if condition, that is ptr of next equal to null. This condition is true, then it will store all these variables, the ptr of next to temp and null value as ptr of next, and it will print no deleted. If that case is also not true, then it will go to the else part where all these values will be stored into the particular variables, like ptr of next value will be stored into temp, and temp of next will be stored into ptr of next, and ptr will be stored into temp of next and temp of previous, and print non deleted. Then moving on to the search function definition. ptr, again we are declaring a struct node, and the integer variables item I equal to 0 and flag, and heads value will be stored into PTR, and using if condition we are checking whether PTR equal to null. If that condition is true, that means the list is empty. Then moving on to the else part, we are asking the user to enter a number which he wants to search to get the particular location of it. So then we are using a while loop. We are checking PTR not equal to null. If condition is true, then it will go to the if part, that is PTR of data equal to item found at location, and will print location, and it will give flag equal to 0 and break. If this condition is false, then it will go to the else part where flag is equal to 1, and that means the entered number by the user for searching is not present in the given input. So that is why flag equal to 1 we are giving in the else part, and if flag equal to 1, then it will print item not found. Then comes the display function definition. Again, struct node PTR has been declared, and we are giving a printing a thing statement like printing values, and we are storing heads value into PTR. Using while loop, we are checking PTR not equal to null. This condition is true, then it will print the value of PTR of data and store PTR of next value into PTR. So let's run. So here I'm inserting in beginning, first option, and giving 20 as the value. Again I'm inserting 1 in the beginning, giving 30, again 1, 40, and I'm displaying it 8. So the values we already have is 40, 30, and 20. Now I'm inserting at end. I'm in the second option, so I'm giving 60. Then inserting at any random location, that is 3. I'm giving 2, and giving the value and the location as 2. So no, it's given not inserted. Now I'm displaying it 8. So see 20, 30, 20, and 2 has been inserted. The value 2 has been inserted at the uh, location 2. Now we go for fourth one, delete from the beginning. So no deleted, and so we'll just display it and see. So 40 has been deleted. Now we'll go for delete from last, that is fifth one. So it will delete 60, and we'll go display it. So 60 has been deleted, only 30, 20, and 2 remains. Now delete the node after the given data. So I'm giving 6. So here 30 and 20 and 2 is remaining. So I want to delete 2. So I'll give 20 so that 2 will be deleted. So now I'm displaying it. So 30 and 20 will be displayed. Now I'm giving 7 search, that is 30. So it will give the item found at location 1. And now so this is doubly linked list. Thank you.